This is a problem from earlier. You notice we had standard RC and RE, and however this is really not very practical. So what we do with this is we use a couple of resistors in place of this so that we can create a voltage divider, and we can bias this base here to a particular voltage so that we can get a particular VCE. So let's go into that and we'll see. Okay, we need to, this is a typical voltage divider network common emitter circuit. We have a R1 here, an R2, which is a basic, just a voltage divider, and if VCC is equal to 10 volts, then the voltage here will be, because of this voltage divider here, we have a little problem with the amount of current here going through this. So if we have a KVL this circuit, we're going to have to do it 3 times. So KVL loop for 1, let's see, let's make it this one. This loop here, current goes here. KVL this guy, we have start out at ground, and then go to the 10 volt source here. So we have $10 minus, how about ICRC, that's this one here, minus, oh, how do we deal with this? We have voltage collector to voltage emitter, so we'll call that V collector to emitter, minus voltage ICRE, basically ICRE, and that's all equal to 0. So let's KVL the next loop, which is, let's go with red here, this one here to this one here. So KVL, start out with 10 volts minus I1 R1 minus I2 R2, or actually it's I1 because it's relatively the same current here as here. It's equal to 0. Now we'll go through why that's not exactly true, but let's KVL the last loop and we'll see why. So let's do that one in blue. We have KVL this loop. We have it going this way and current this way. So that starts at ground, goes 10 volts minus I1 R1 minus, oh, what? We have a 0.7 volt drop here. 0.7 volt drop minus IERE is equal to 0. So we have a current flow through the base this way and through the emitter resistor. So we have voltage drop here, one here, and one here for that one. So we actually have a couple of different places the current flows in this circuit. Now there are two different ways of figuring out this circuit. Let's try the quick and dirty, or not so accurate method, which ignores base current. It's basically okay if beta DC is equal to, I suppose, greater than 100. So let's have a look at this. What is the voltage at this point right here? Voltage at that point right there, if we have 10 volts, it's basically just a voltage divider. So we have 10 volts times R2 over R1 plus R2, which is equal to 10 volts times 2.2 k ohms divided by 12.2 k ohms. And that's equal to, I'll have to get my calculator out and figure it out.